Have you ever wondered how ND arrays are created? Well, you're not alone. ND arrays, short for n-dimensional arrays, are the backbone of data manipulation and analysis. They provide a robust way to handle and process data in multiple dimensions, making them indispensable in the realm of data science. Imagine being able to work with data not just in 1 or 2 dimensions, but in as many dimensions as you need. The versatility of ND arrays is truly remarkable. From image processing, which often requires 3-dimensional data, to machine learning, where multi-dimensional inputs are the norm, North Dakota arrays are everywhere. They're also vital in scientific computing, where complex models often demand multi-dimensional data structures. So, why should you care about ND arrays? Simply put, they're a powerful tool that can help you handle and analyze data more efficiently and effectively. By the end of this video, you'll have a better understanding of ND arrays and how to create them. Creating an ND array might sound complicated, but worry not, it's simpler than you think. Let's break it down step by step. First off, we need to make sure we have the right tool for the job, that being the NumPy module in Python. If you don't have it already, you can install it with pip, Python's package installer. Once we have NumPy, we can import it into our Python script with the line import NumPy as np. Now let's dive into the actual process of creating an ND array. The basic syntax for creating an ND array is numpy.array object dtype =none. Let's break this down. The first parameter, object, refers to any array-like object. This could be a list, a tuple, or even another array. Essentially, it's the data that we want to turn into an ND array. The second parameter, dtype, is optional and specifies the desired data type for the array. If you don't specify a dtype, NumPy will try to figure out an appropriate data type based on the values that you've provided. It's useful when you want to ensure your array contains a certain type of data, like integers or floating point numbers. So, to create a simple one-dimensional array from a list of numbers, we would write numpy array. This would return an array with the numbers 1, 2, 3, 4, and 5. If we want to create a two-dimensional array, we can pass in a list of lists. So, numpy array would give us a two-dimensional array with 2 rows and 3 columns. Now, if we wanted to ensure that our array only contained floating point numbers, we could specify dtype =float when creating the array. So numpy.array dtype =float would give us an array of floating point numbers. And there you have it, the basics of creating ND arrays in Python using NumPy. Now that we know the syntax, let's move on to some practical examples. Understanding the theory is good, but applying it is even better. So let's jump straight into some practical examples of creating ND arrays. We'll start with a simple one-dimensional array. Imagine you're trying to store the ages of 5 people. The syntax might look something like this, ages =np.array. What we've done here is create an array using the np.array function, and we've passed in a list of ages. When printed, this array will display the ages in the exact order we've entered them. Next, let's move on to a two-dimensional array. Perhaps you're tracking the ages and heights of these 5 people. This time, your syntax might look a bit more complex. Something like ages_heights =np.array. Now our array has 2 dimensions, represented by 2 brackets at the start and end. Each inner list represents a person with their age and height. Finally, let's create a 3-dimensional array. Imagine we're adding weights to our data. The syntax becomes a bit more involved, but don't be intimidated. The structure and logic remain the same, it's just nested one level deeper. As you can see, creating ND arrays is not as daunting as it first seemed. You're now equipped with the knowledge to create and manipulate your own ND arrays. So, what have we learned today? We've unlocked the concept of ND arrays, delved into their creation, and even explored real-world applications. We've understood that ND arrays are multi-dimensional container of items, all of the same type and size. We've learned the process of creating them, using specific syntax and commands. We've also seen how they can be used in practical scenarios, enhancing the efficiency of our code. Now you can confidently create ND arrays and harness their power in your programming tasks. Keep practicing, and you'll master it in no time.